Okay, thank you, Dr. Ramji, for giving me this opportunity to chair this session. And I like to just brief about this. This session has around 5 lectures on different issues relating with the palm. And just to further information of the candidates, those who are presenting, this is all going to be a very competitive event. It is being evaluated based on the originality, novelty, scientific soundness, presentation skills, quality of the slides, presentation knowledge, as overall performance. This is just not to just to give a thought that how well the people, the presenters have presented it here, and we'll be just, it is all, everybody will do their best. Only thing we need to give some awards, so that's why we are trying to do this one. So in that way, the first presenter is from Dr. Noor Anwar, and he is from the Universiti Teknologi, Malaysia. And please, when you, I don't have much introduction about the speaker here. When you start this your lecture, please say 2 lines about yourself, whether you are a faculty, you are a student, is that your research area, and that's because we will know about your position in the university. Okay, can I invite Dr. Noor Anwar for the presentation? Is available? Can the host make Dr. Noor Anwar for the presentation of the slides? Yeah, you can take.
Mrs. Noor?
Yes, Mrs. Noor is now co-host. You can unmute and you can share your screen for the presentation. Thank you.
Unmute, okay.
Perfect now. Just share, we can start to share your presentation, please.
Okay, I'm sharing my screen right now. Share screen. So everyone can see this slide?
Yes, we can see. Please
Yes.
just give two lines about yourself. We want to hear from you.
Okay. Hi, good evening from Malaysia. I'm Nur Amira Khairina binti Khairi Anwar. I'm postgraduate student from Universiti Teknologi Malaysia under Faculty of Chemical Engineering. Yeah. So my supervisor is Prof. IR Ani Idris.
Thank you. Please go ahead
Okay.
with your presentation.
Okay, so today I'll be sharing my research entitled Large Scale of Bio-succinic Acid Production from the Inorganic Salts, Pretreated or Palm Empty Fruit Bunch using Actinobacillus succinogenes. So what is actually succinic acid? It's also known as a butyl acid. It's an intermediate in the tricarboxylic cycle during fermentation process. So this particular compound is being widely applied in many fields, including pharmaceutical, cosmetic, food additive, and also biodegradable polymers. So traditionally, the succinic acid is being produced by a chemical process, which is through dehydrogenation of malic anhydride. But due to the high price in the oil, research has shifted to the production of succinic acid using pure sugars such as glucose, xylose, and also other type of sugars. So for the past few decades, a study also tried to produce succinic acid via fermentation process using biomass. All right, so these are the example of the succinic acid derivative. Okay, as you can see here, there are many compounds that can be produced from the succinic acid. Okay. So basically, the bio-succinic acid market has been marketed globally. Okay, as you can see on the left side, the market is keep increasing from year to year. So on the 2020, the market of bio-succinic acid has reached around 710 kilotons production. So it's being widely applied in many fields. Okay, including food application, pharmaceutical, industry, and also cosmetic. All right. So the idea of producing bio-succinic acid in the large scale is due to mainly because of the higher cost in the crude oil And then there's also a demand in the renewable chemicals and the investment for the green chemicals. On the other hand, they're also due to the increase of awareness and the government support. However, there are also factors that still holding back the global bio-succinic acid market due to the higher price of bio-succinic acid method and bio-succinic acid product. And also the downstream process is quite lengthy and expensive. So many countries that took part in the bio-succinic acid production, including North America, Europe, Asia Pacific, also the other country as well. Okay, so the global succinic acid market, okay, on the right side of the figure shows that during on 2014, the production reached almost 100 kilotons per year. So as time goes by, the production is keep increasing. Therefore, it also increased the revenue of the bio-succinic acid market. So I put one example on the European country. So during 2012, the revenue made by the country was nearly less than 100 million US dollar, but the revenue keep increasing from year to year until 2017. There is a drastic increase in terms of revenue, and there is steady growth of the revenue for the bio-succinic acid market. Okay, there are many companies that took part in the bio-succinic acid production, but here are the 4 main companies that is being highlighted. Okay, including Succinogy, Revidia, Myron, also BioAmber. So on the average, this company produced around 10 to 14,000 bio-succinic acid per year, but BioAmber doubled the production of the other companies. So different companies using different strain to produce the succinic acid. For example, BioAmber using E. coli and Candida krusei. For Succinogy, they use Bacteria succinoproducent, which is bacteria. Myron using E. coli, Revidia using Saccharomyces cerevisiae. So the idea of producing succinic acid from biomass, there are 2 approaches. Okay, basically we use the biomass. From the biomass, we collect the cellulose, and then the cellulose will be converted into sugar. So the sugar will be used as a starting material to produce succinic acid. Okay, the separate hydrolysis and fermentation. Okay, this 2-step fermentation process where the hydrolysis of cellulose into glucose or other type of sugar will be conducted in separate vessel, and then the hydrolyzed collected will be used as a starting material for the fermentation process. So basically, the process is quite lengthy compared to SSF, where the SSF approach, we combine both hydrolysis and also fermentation in just one reactor. So basically, the cost is lower, the fermentation time is lower, and also the risk of contamination is lower. Okay, so these are the overview of my research. So from the raw empty fruit bunch, okay, it will undergo so-called as physical pretreatment process to process the EFB and become a small particle. So from this small particle, it's subjected to the inorganic sub-pretreatment, and then the pretreated EFB will be washed and dried before being used for fermentation. So this reactor shows these are the schematic diagram of my research setting. So basically, I add EFB as a substrate, cellulase, the inoculum, which is Actinobacillus succinogenes, and other different components, including acid and base to regulate the pH, CO2 gas. So this 16 liter containing fermentation broth with the succinic acid. So at the end of the fermentation, the broth will be collected, filtered, evaporated, and the concentrated succinic acid will be obtained. So on the left side, these are the real setting of my bioreactor. Okay, so these are the specific diagrams. So basically the same. I use the pre-treated EFB, the cellulose enzyme, also Actinobacillus succinogen as the inoculum, and then I add into the reactor and undergo the fermentation to produce succinic acid. Okay, so for each step, okay, for the pre-treatment, I implement physicochemical approach where I use 15% trisodium phosphate, and also 5% zinc chloride to pretreat the OPEFB. And then for the inner club preparation, I use Actinobacillus succinogen as the microorganism. So I need to prepare the seed culture using tryptic soy agar. And for the fermentation, I use the fermentation media that contain nitrogen source and other traces material. So the fermentation is being conducted at 37 degrees Celsius anaerobically. For large scale fermentation, I studied two approaches. First is conventional SSF, and then the second one is modified SSF, or we call it as semi-SSF. For the conventional SSF, it's been carried out for 72 hours, where we done everything, EFB, media, cellulose, also inoculum, to hydrolyze the biomass and conduct the fermentation. But for the modified SSF, okay, the hydrolysis being conducted beforehand, where I add EFB, cellulose, and water, okay, to release the sugar at its maximum amount. So the temperature is 50 degrees Celsius. And then after the sugar being produced, I proceed with the fermentation using at 37 degrees Celsius by adding the media and also inoculum. So the sampling is being done every 12 hours to measure the reducing sugar and also succinic acid. So the outcome of the research for this conventional SSF approach, okay, the graph explains that on the 12th hour, the maximum sugar that we obtain is around 0.3 gram per gram at the 12 hours. So after 2 hours, the sugar started to deplete, but the succinic acid concentration started to increase. Okay, this shows that the bacteria already started to consume the sugar to produce succinic acid. So the maximum succinic acid that we managed to obtain is around 38.85 gram per liter. All right. For the modified SSF, where I explained that I did the hydrolysis part beforehand. So throughout the 72 hours, we can see that the sugar started to increase on the 12 hours.
Dr. Noor Ahmad, can you please complete your presentation in 3 to 4 minutes? Come to the conclusion.
Okay. So, the sugar, maximum sugar that we obtain is around 0.79 gram per gram. So the factors that influence the high production of sugar due to the temperature and also the absence of media. So basically, these are the outcome. All right. So from that 72 hours, I prolong another 72 hours to produce succinic acid. So the maximum succinic acid that we obtain is around 50.5 gram per liter, which is relatively higher compared to the conventional SSF. So these are the small scale research that I've done previously. Okay, so the same setting but in a small scale, which is 50 ml serum vial, and the production is 65.2 gram per liter. So comparing the small scale and large scale, I can see that the small scale produce the highest, meanwhile followed by the semi SSF or modified SSF, and the lowest is the conventional SSF. This is due to the high biomass loading in the bioreactor, the poor mixing, and also the accumulation of inhibitory compound during the pre-treatment process. So to my best knowledge, these are the findings I managed to compile, and I can say that semi-SSF approach is the best and the promising method to enhance the succinic acid yield in the large scale setting. Okay, so therefore further improvement can be done to boost the succinic acid yield in large scale setting. And in addition, this research provides also an insight or preliminary data for the industrial application of succinic acid from the biomass. Lastly, I would like to thank Universiti Teknologi Malaysia and also Ministry of Higher Education Malaysia for granting me the fund to conduct the research. And this research also has been patented under the Malaysia patent application. So these are the references, and thank you so much.